Hey everybody, we are headed to our final chapter for algebra, which is about inequalities. If you don't know the word inequality, if something is unequal or unequal, it is not equal to. So if you take a look at all those equations over there, they don't have equal signs, but they might have a less than sign, or they might have a greater than sign. Or this one would be a less than or equal, which is that little, you can kind of see the equal sign is kind of built in there, but then it still has the less than sign. And then this one would be a greater than or equal, because it has a little bit of that equal sign kind of built into it right there. So hopefully you're familiar with those, and we're going to use those to solve these inequalities over here. If you're pretty solid with solving for x, with solving equations, solving inequalities is almost the exact same thing. There's just one tiny little difference, and we will get to that. So we're going to go ahead and take a look at number one. I'm going to phrase number one how you might see it on like a standardized test, the SAT or the ACT or the state test. 5 is combined with a number. So can you think of a number that when it combines with 5, it is less than 9? So do that real quick in your head. Think of a number that when it's combined with 5, it's still less than 9. So you might be thinking, oh, if 5 combines with 1, that's definitely less than 9. If 5 combines with 2, that's less than 9. If 5 combines with 3, those are all answers that are less than 9. 5 combined with 4 is 9. That's not less than 9. So if you thought of an answer like 1, 2, or 3, that's great. You could have also thought of 0 or -1 or -2 or any negative number. So how do you represent the numbers that are 1, 2, 3, 0, right? 0 combined with that would be less than 9. Any negative number, 5 plus a negative, is going to go down. That's definitely going to be less than 9. How do we represent all of these numbers? We use an inequality. All right? So this would be all the numbers that are 3 or less than, right? Because this would be ... headed over that way. So all the numbers that seem to be 3 or less than. So let's go ahead and use some algebra skills, solve this, and see what happens. So for number 1, we go ahead and we take 5 plus n, and less than 9, we subtract the 5. We just pretend that this is an equal sign, right? We just bring down that it's a less than sign, but we just bring it down, pretend it's equal, balance it out. Whatever you do to one side, do the other side. We all know how math works, right? So the 5's cancel out, and we get n is less than 4. Which, if you think of those numbers we had, you can kind of see them here, I erased. Aren't all these numbers right here less than 4? Yeah, I bet a number that maybe you didn't think of in the beginning. Think of a number that when you combine it with 5 is less than 9. What about like 3.1? That would be less than 9. That would be 8.1, right? What about 3.2? 3.3? So just listing all these numbers would take forever, like to put 3.1, 3.2, 3.3, and then I'm still missing 3.31, 3.32, 3.33. There's a lot. So all the numbers that are less than 4, that's how you show all of those possibilities of answers. So it's really nice that this little simple inequality really covers all the numbers that are less than 4. 3.9, 3.8, 3.7, 3.71, 3.72, 3.73, 3.74, all those numbers, all the negative numbers are included in this as well. Right? So nice, pretty easy. If we can solve algebra, it works out pretty well. Take a look at number 2. I'm going to phrase number 2 how you might see it on a standardized test as a word problem. If you take 7 and you subtract a number, what number could you do that you subtracted from 7 and it's still greater than 3? Can you think of a number that you can go 7 minus that number, but it's still greater than 3? Like 7 minus 1? That's still greater than 3. 7 minus 2. Yep, that's still greater than 3. 7 minus 3. Yep, that's still greater than 3. 7 minus 4. That's not greater than 3 anymore, that's equal to it, right? So maybe these numbers, 1, 2, 3, would help us out. Did anyone think of a negative number? Did anybody think of 0? 7 minus 0 is 7. That's still greater than 3. So what we're going to do is we need to come up with something that was going to give us these possibilities of answers like 1, 2, and 3. So let's go ahead and do the problem. 7 minus n is greater than 3. Is a positive 7, so subtract 7 from both sides. We have negative n is greater than 3 minus 7 is negative 4. Yeah, we didn't really solve for numbers around negative 4. It looked like we had like 1, 2, and 3 would work for this, right? And we have n is greater than negative 4, but it's a negative n. Think of this as negative 1n, which is what it exactly is. And how could I solve for n? Divide by negative 1. And now we cancel that out. We have n is greater than 4 divided by 1 is 4. Negative divided by negative cancels out. N is greater than 4. Are these n's, are these numbers greater than 4? No, they are not. This is the only thing that's different when you're solving inequalities. Whenever you multiply or divide by a negative, like we had negative n here, and it flipped to a positive, what you're going to do is flip your inequality sign. All the numbers that are less than 4 are the numbers that would work for this. Think of a number less than 4, 3. 7 minus 3, yep, that's greater than 3. Think of a number that's less than 4, like 1. 7 minus 1 is 6. 6 is greater than 3. This is the only thing that's different about inequalities. If you ever multiply or divide by a negative, so you're flipping the sign, we're going to flip our inequality sign. Let me go ahead and show you a different way you could have done this from the beginning. If you don't want to have to remember that, like I don't like remembering tricks, and that's kind of like a trick. So here's something I could have done differently instead. Whenever you have a negative variable that you are trying to solve for, move it to the other side and make it a positive variable. These cancel out. Do I have to flip the sign? No, because I did not multiply or divide by a negative. I just moved a negative, I added a positive over here. How do you feel about solving this? Four is greater than n. 4 is greater than your number. So you need to think of a number that is less than 4. Read it backwards. Number n is less than, you see how you kind of see the small part of the inequality? So if 4 is greater than your number, then your number is less than 4. So can you think of a number that's less than 4? Sure, 2. 7 minus 2? Yep, that is greater than 3. So the negatives have a little bit of a tricky thing to them. We're going to come up and do a couple more of the negatives in a second, but the rest of these should go pretty smoothly and go pretty quick. So if you didn't catch that just yet, don't worry about it. We're going to come back to it, get you a couple more practice problems. But for number 3, how do we solve this? We just pretend it's an equal sign. You just solve like you did in algebra back in middle school. You balance out your equation. You bring down this inequality instead of the equal sign. 7 minus 1 is 6. Divide by 2. X is less than or equal to 3. All the numbers that are less than or equal to 3 would work. So like that's a number that's less than 3, that's a number that's less than 3, that's a number, these are all numbers that are less than 3. Oh, but it does say equal to 3, so that would also be an answer. 3 would also be an answer. How do we do it? We just do algebra like we did in middle school. Alright, so these ones will go a little bit quicker like I said. Here's number 4. 8x minus 5 is greater than or equal to negative 3. Do we have to worry about that little negative trick? No, we do not have a negative variable. Just go ahead and solve algebra. Let's go ahead and do the math that you guys know how to do. Positive 5 minus 3, or negative 3 plus 5, divide by 8. 2/8 simplifies to 1/4. You could go to a decimal, 0.25 if you wanted. All the numbers that are less than or equal to 0.25. Cool, we just do algebra, we just do math. The only thing we're worried about is if we have a negative variable. Take a look at number 5, we have a negative variable. You have two options. First option is to go ahead and solve for the negative variable, but remember when the negative variable flips to a positive, you got to flip your inequality sign. The other option is, right off the bat, go ahead and move the negative x's to the other side. The negative 2x's will go to the other side and become positive, and now you could solve that one. Doesn't matter to me. Let's go ahead and try solving for the negative variable. Here's a positive 11. I'm going to subtract 11. 11 minus 11 cancels out. We got negative 2x. 1 minus 11 is negative 10. Here's the only thing different about inequalities from equations. If you ever divide by a negative, or you multiply by a negative, dividing and multiplying are kind of the same thing. If you divide by 2, it's the same as multiplying by half. Anytime you divide or multiply by a negative, right here, I had negative 2x's, look. Now I have a positive x. So if you ever divide by a negative or multiply by a negative, that's going to flip your x's from negative x's to positive x's. You then have to flip your inequality. If you do not want to remember this trick, then you simply take your negative x's, you move them to become positive x's, and now you solve for your positive x's. Look, it's pretty similar, right? Are those the same equation? Well, let me ask, is the inequality the alligator eating towards the same number? Here, the inequality is opening up towards the x. Here, the inequality is opening up towards the x. These are the exact same thing, right? Is this x is greater than 5? You could read this one as x is greater than 5 because you're seeing the opening first. X is greater than 5. Or you could say this is 5 is less than x. 5 is less than, because you see the small part of the alligator mouth. 5 is less than x. You could also read this one backwards. 5 is less than the x, because you're seeing the small part first. So make sure when you have these inequalities that you're reading them probably from the x is the easiest way. X is bigger than, is greater than the 5. X is bigger than or greater than the 5. Cool, there's two ways to solve a negative, and number 6 is also a negative, so we'll get a little bit more practice, and then I'll give you guys one to do on your own. Number 6, notice right off the bat we've got negative x's, so you've got a choice. Do you want to solve for the negative x's, or do you want to move them to the other side right away? So that negative 12x's become positive 12x on the other side. And do you want to solve for a positive x? I'll go ahead and solve for the positive x. Feel free to pause it if I'm going too fast. Two over 12 simplifies to 1/6. Let's see if I get the same thing over here, solving for a negative x. Here's positive 10. I'm going to get rid of it. I have negative 12x's and negative 2. Take a look over here. I have positive 12x's and positive 2. So it's going to cancel out, be the same thing in just a minute. I am dividing by a negative. I'm taking the negative x's and I'm turning them to positive. I'm flipping the negative x's to positive. I have to flip the inequality. Negative over negative is positive. 2 over 12 is 1/6. Are these the same? The x is on the small side of the inequality. The x is on the small side, so this is x is less than 1/6. X is less than 1/6. Or you could say the 1/6 is greater than the x. The 1/6 is greater than the x. And it should have been greater than or equal to, or less than or equal to. You can do it either way, it doesn't matter to me. Alright, number 7, that's going to be your problem to try on your own. See if you can come up with the answer for number 7. Again, I'll write it a little bit bigger for you, just so you can see. I'm not giving you a challenging one to do on your own. It does have a negative, but are they negative x's? Nope. Just go ahead and solve like you learned in middle school. What's the answer to the number 7 inequality? You can do that on your own over there. And then number 8, I'm going to throw in a fraction to wrap up today. We got 1/2 x. There is a negative, but it's not negative x's, so I don't have to worry about that extra trick or that one thing that's different. I don't have to make my negative x's into positive x's. I just go ahead and solve like I always do. Balance out the equation. Add 3, add 3. I bring down 1/2 x. I bring down the inequality sign. That's less than or equal to. Positive 3 minus 7 is negative 4. Or I could do negative 7 plus 3 is negative 4. How do you divide this? Well, you can turn it to a decimal if you want. I just like to go ahead and divide by 1/2, which is the same thing as multiplying by the reciprocal. Remember when I said that multiplying and dividing were pretty much the same thing? If you ever want to get rid of 1/2 times, you could divide by 1/2. You can also, so you don't have to use a calculator, just multiply by the reciprocal. So if I multiply by 2/1 on both sides, that's balanced out, right? Now the 2/2 is going to cancel, the 1/1 is going to cancel, the x is by itself, and it's a little bit easier to do negative 4 times 2, which is negative 8. Negative 8 divided by 1 is negative 8. That's a little bit easier to me than dividing by 1/2. Sometimes kids mess up dividing by fractions. So I would recommend this right here, which is called the reciprocal. Alright, so if you want to get rid of 2/3 x, you would do 3/2. If you want to get rid of 2/4 x, you would multiply by 4/2. You want to get rid of 1/5 x, then you multiply by 5/1. So you can use that reciprocal to help you out. You'll use that a lot in geometry next year, which is why I definitely wanted to mention it to you today. Remember your problem that you got to do. What's the answer to number 7? Have a good one.